Hey, hello. This is the continuation of the Nephio Release 1 learning video series. This particular video is about the, the Nephio Release 1 free5gc operator. And so this I predates all of this before I start. I would like to say that I assume audience have already watched one or more, at least some intro, if not all of the previous videos posted for learning. So I would not go deep into a Nephio architecture or Nephio concepts or anything in terms of um, um, some of the modules of management clusters and things. I expect audiences would have already watched this. And also, I assume for this video that audiences would know what the components of the 5G cores would have. So I'm not going to explain what a AMF or SMF or UPF those components are doing in the context of 5GC, 5G core. So something that you can easily read, obviously, online. But then because you're interested in Nephio, I would also assume that you already know what 5G core is and what they're doing and what all the various different network functions are within 5GC. With that, just to level set, the network function operators in Nephio architecture plays a role of basically um, taking on, they run on the workload clusters. So what would happen is when you're creating when you push your high level intent onto Nephios, and then Nephios start creating the instance per instance packages, and then the specialization logic start inputting values based on your location, which instance and things into the final package. That package get pushed to the workload clusters, and the workload clusters would have a Nephio defined custom resource in there. Depends on which network functions. It'll be one of the AMF, UPF, or SMF deployment custom resource, and correspondingly, the operator actually contains all of them. So in this case, for free5gc, that operator listens to that custom resource, um, and then wakes up, and then it would process and realize that intent based on very vendor specific logics. So that's the role of a network function operators in the context of that field. So the little red circle and the big red arrow over here shows you that the operators, the network function operators, sits here. And then this presentation is mostly about, for our one, we only have one, which is from free5gc, a project called free5gc. You can see that from free5gc.org. What it actually does is basically a open source implementation of 5G core. And then we only support a deployment scenario. So it's not a lot of, the configurations are all about deployment of the network functions. So different three specific 5G core components, network functions, AMF, SMF, and UPF, are the things that we have implemented for release one. And then they correspondingly have their own custom resource definitions. And then if you created a correct resource, custom resource based on that CRD, and if you do all the prep works on the target clusters for free5gc, it would create a working instance of that free5gc network functions that you want. So that's what the operator is doing. Before we jump into that, the big thing is there is a actually I spelled this one wrong. Instance. It would be worthwhile to understand what the custom resource definitions that we have done for release one, Nephio release ones. So we have three of them, this is basically our interface between the management clusters, which will be generating the packages, and the workload clusters would be trying to actuate and realize that intent. And there are three of them. Although there are three of them, which is each of the network functions, as I said earlier, AMF, SMF, and UPF are the only three that we support at the level of the operator. They're basically the same structure. So we make a concerted effort to generalize each of this at the detriment of actually over-define some of the structures. But then all of them basically contains a single structure called NF deployment. And what's inside NF deployment is capacity. So capacity is actually different for AMF, SMF, and UPF. But then we kind of pack all of them together as a single structure. AMF, they care about maximum subscribers. For SMF, you care about maximum sessions and maximum number of network functions that are connected. So this reflects on how many UPF that you're managing on an SMF. And then for UPF, is maximum throughput for both uplink or downlink. And so the five parameters that I just talked about, all of them get packed into a single capacity structure. So that's actually part of the NF deployment. You have a list of interfaces. The interfaces by and large basically carries an IP address, v4 and or v6 in the VLAN information. So it's network information on that interface. That's a list of network instances. One of them, which we have not exercised on R1, is the BGP config. So we can ignore that for now. The other one is for data networks. The only network functions where this is actually relevant is UPF. For UPF, as I mentioned earlier, I expect audiences to know what UPF does. For UPF, a non-IUPF would have an N6 that goes into data networks. That data network information is contained within the data network structure. And then config ref is being used for vendor extensions, and we can talk about that later. So before we even go into how we do how we build the free5gc operators, we have to first understanding what is needed before you can spin up an NF, SMF, AMF, SMF, and UPF from free5gc. So forget about the operators for now. If you are manually doing it, you need to do a kube control apply -f the manifest to create a deployment or a config map to create an SMF or UPF or AMF or AMF, what is actually needed to be done before you can even do that. So one of the things the first thing you do is install Multis. So, well, you have to create a cluster, obviously, but that goes without saying. And on that cluster, you have to install Multis. Multis, brief introduction, again, something you can read, audiences can read about. Multis is one mechanism. And for Kubernetes, by default, you have one network interface on a pod. And Multis allows you to create additional interfaces on the pod. So we normally call all the other interfaces that are created by Multis secondary interfaces. So and then each of that secondary interfaces, you can by options, you can bind them to a different CNI binaries. So think of MAC VLANs, SRIOV, it could be IP VLAN and some other things, bridge. And then, so for this, you have to also install the CNI, this CNI binaries that you actually care about onto /ops/CNI/bin onto other nodes that you can possibly run free5gc AMF, SNF, and UPF. And for nodes that are running, you're allocated to run UPF, you should install GTP 5G, which is a kernel module that is needed by UPF for basically the GTP tunnel to the GNOB on the RAN side. And then likewise for AMFs, for other nodes that runs AMF, you have to install SCTP, or actually enable it for some of the kernels that are already built in. So at least turn it on. So SCTP is to be running on the AMF nodes. You obviously would have to, for all these secondary interfaces, so Multis or Kubernetes does not manage, as we talked about earlier, Kubernetes does not manage any of the secondary interfaces. So for this, you have to allocate your IP address and basically explicitly specified to the system that they're going to use those IP addresses for all these secondary interfaces. In order to use those secondary interfaces, before you can apply a deployment of a UPF, an SMF, or AMF, you have to correspondingly define the NADs, what we call the network attachment definitions, or NADs. NADs are definition constructs, basically a template that defines what would be used for that secondary interfaces that you want to use when Multis creates it. So the creation doesn't happen until your pod get instantiated. Then based on the annotation of the pod, they know which NADs they're supposed to realize at the moments of creations. But you have to define those network attachment points. You also have to, obviously, it goes without saying, for 3GPP related configs like PLMNs, and if you have slides information, you can use that. That also is needed. And most of those goes into the SMF configurations. I think one of them at least goes into AMF, but then UPF doesn't need it. So, but then you have to have those information in place. So this is the eighth one is a very interesting one and a very free5gc specific. The free5gc SMF configs requires a lot of information of all this connected UPF. So we'll talk about that later. But you do need to get your UPF in order before you can fully write up a workable SMF configurations on free5gc. And then obviously it goes without saying, if you want to do traffic test, your client, which we use UE ransom for release one, you have to also match the IP addresses that are expected and all the 3GPP informations that are expected. So, but what does the Nephio free5gc operator do then? So the first thing it does is the reconciliation loops of an operator, each of the controllers. So how we structure the Nephio release 1 free5gc operator is it's just a single binary. It's a single operator. So one manifest for you to apply to create it. It contains 3 controllers. Each of the controllers watch the AMF deployment, SMF deployment, or UPF deployment custom resource. And then the reconciliation loops basically takes that, reads that object, any change or any creation or deletion of these objects, type, kind, and it will reconcile based on that intent. And then what it does is, so very early on, we as a community decided that the operator would at least be managing the network function specific configurations. So for free5gc, this is a form of a config map. And the deployment has a dependencies on a config map. So because of this, the network function operators manages config maps and deployments. We also make it manage service because, if you have an operator, it might as well. So the service in this particular case, service name is the only thing that really matters. So in here, AMF and SMF would create the controllers would create deployments, config map, and the service Kubernetes objects based on the CL that you sent that one sends down. And then for UPF, it's only 2, so deployments and config map. What it does when you take that CL, corresponding network function deployment CL, is that it would calculate the resource needs. So in our case, it's still pretty early for R1, so it has hard code, simplistic things that we want to demonstrate more than anything else. So it reaches a certain threshold, we will be requesting more CPUs and memories, but if it drops below, then we'll request less. So that's what it does. And then, yeah, based on the deployment CLs as input, we'll also be able to create deployments in config map and servers for the other 2. And it manages the dependencies. So we have at least the dependencies of NADs, corresponding NADs that we expect, and then we'll ensure this is working. And then we'll also enforces the order that obviously config map needs to be created before you can create a deployment. But then all the other infrastructure needs, like the kernel modules and things, we just assume is there. And then we associate the objects that we are going to create with the custom resource. So if you delete the custom resource, the corresponding Kubernetes objects also get deleted. And then we also update the statuses of the deployment. On any of these deployments, AMF, SMF, or UPF deployments, their statuses are exactly the same also. So it's still very simple. It's more like conditions and how many pods are running, type things. And then timestamps on when it does start running. Ensures that and then we also make sure, this is one of the, not late, but intermediate development additions. If you update any things that affects the updates of the config map. So for example, if you are creating if you're updating a free GPP information, which affects only the config map, it doesn't affect the deployment object. It would also lead to deployment updates, because on free5gc, it's config map, and it doesn't wash the config map. It just kind of loads it once. So you have to reload the config map, which is the simple part. The second part is you have to kill the existing running network function pod, and then make it run again. So we'll reload the new config map, the updated config map. So the free5gc operators today does that. So if you update anything that causes an update to the config map, it would also update the corresponding deployment for that particular UPF instance or network function instance, and then it would correspondingly, therefore, reloads the network functions pod deployment. So now that we know what it does, very quickly you can see what it, in practice, what it does. So in this Windows, I'm running it as a main. So I'm not even running the entire Nephio pipeline. In here, I'm showing you how to run the operator by itself. And then if you have if you make sure all the dependencies are done, and then just apply the custom resource, that the Nephio custom resources, then you'll see that the network function will be running. So we are doing it for, in this case, UPF. So f1.yaml. So as I talked about earlier, so this has capacity, all the interfaces, config, all the network instances, and there's nothing for config ref. There's no vendor extensions for UPF in our case. So if you decided all your IP addresses that you're going to bind to an N3, N4, and N6, and then you define your capacity, then internally, all they're looking for is a corresponding N3, N4 NADs. So you have to also create those NADs prior to actually applying that custom resource. So in this case, you can see that I've already done it. I created a free5gc namespace, as you can see earlier. This is going to the free5gc namespace, or actually the real thing, the actual CL, the UPF deployment CL. You can see that they're going to the free5gc namespace, and then they're expected to see something called UPF 1 and 3 and 6 or and 4. Well, actually no. So they're expecting to they're expecting to see your name, your deployment name, and the corresponding interface as a name of the network as NAD. So we kind of predetermine that. And in that case, also, as you can see, the GTP 5G kernel modules already loaded. This is the node for UPF. So this is already loaded. So those are the dependencies I talked about. When this is in place, what you would be able to do is so for now, just to make sure that we're not just pre-port everything, you can do a get all dash and free5gc. It's actually not much of anything inside. As we said, as we talked about, we're also creating config maps. So you can see that we only have the cert, but nothing else in the config map. So at the moment, if we start applying this YAML, what you'll see is the what is running. Actually, it doesn't even take that long anymore, because the image is already loaded earlier. And you can see it's running for 9 seconds. So this is based on the custom resource that we're creating. So what is the code structure? So if you go into our Git repo, this is under Nephio project project, the free5gc Git repo, and then you will see that on the free5gc operator directory, you'll find that we have controllers. Under controllers is actually it's a main.co go, which is the main loop, and each of these loads the corresponding couts. And then you'll see each of them has a reconciliation loop. You can see the reconciler. We name it after the reconciler. And they have each of this represents a controller. It's basically a Go routine that is running within the operators. The operator runs as a single binary. And then you see a bunch of controllers that are running. And each of them are watching a different custom resource. And then, correspondingly, AMF watches AMF, SMF, AMF deployment, SMF watches SMF deployments, and then UPF watches UPF deployment. Each of these has a set of resources that it manages. So each directory, you'll see that it's resources .go files. So it depends on who you are. They would be managing the service and deployment or just the deployment. So these are the Kubernetes object that they're managing inside this code. And then also each of this contains a config template. The config template is where you take the deployment information that you're given on cout, and then start filling out the parameters, the inputs that would be creating the config map content for corresponding network functions. So at the end, what it would create, as you can see earlier, is it will create a AMF service and AMF deployments and AMF config maps. Same thing correspondingly for those. UPF doesn't have a service, but then SMF and AMF has services. So this is how our code is being structured. So they're all watching Kubernetes for their corresponding custom resource, and then at the output we'll be creating this. And then once you create this, obviously you'll see the instance running. It's actually very interesting, as we found out as we go, that we need a vendor extension for free5gc. That was not expected early on, but turns out it was needed. And to show you why it was needed is probably worthwhile to check out what an SMF configuration would look like. In an SMF configurations for free5gc, as you can see from here, this is, so by the way, I mean, just credit where credit is due. We make our configurations, we kind of get our configurations of free5gc, our working free5gc configurations from Orange's towards 5GS Helm charts. So this is basically a config YAML. This is a manifest that is created by Helm templates, the SMF Helm charts. So thank you, Orange, for that. And you can see from here that for SMF to run, it needs, well, to run properly, it needs to have the UPF informations, which is actually more than just the N4. So that's the part that actually gets us pretty badly. So they need the information of all the UPF information that you can see from here, from user plane info, all the UPF informations. They need the no ID is what the N for or the UPF, not the N for of the SMF, the N for of the UPF. And also the DNN on all the N6 that you hook up on that particular connected UPF, and your UE pool for that UPF. In 3GPP standard, the UE draws IP addresses from either SMF and UPF. You can do either one of those. These configurations, we use UPF to hold the UE IP address pool. So the UE through GNOB connects to draws an IP address on the UE from the UPF, and then we configure this. It's just that this is not only needed by the UPF for obvious reasons because that's what's working, but then you also need to configure that onto the SMF that is connected, that this UPF is connected to. And likewise, we also need the N3 interface informations, the N3 address of the UPF. So that becomes a full network function dependencies. Basically, so the first one is very well understood. UPF, unlike SMF and AMF and all the other network functions, does not really have an interface into the service bus. So it has no direct connectivity to NRF through the service bus anyway. So you could expose an NRF with a public service name or IP address, and then use DNS. They can talk to that NRF, but then most people don't configure that way. So in that case, your NRF runs with an interface on the service bus. Anything that has a service bus can expose the service name through Kubernetes to an NRF, and NRF will be just looking up the IP address that way. We'll be exposing that to the to someone who inquire. But UPF doesn't. So UPF, even for Nephio, release 1 runs on a different cluster. So they don't register with NRF. So in that case, how the SMF knows which UPF to connect to is basically explicit configurations. So as you can see earlier, when we have the user plane info, we immediately give them a node ID. That node ID is the N4 IP address on the UPF. But you need a lot more than that. And the reason why is in free5gc, the SMF configuration also does UE routing. So it needs to know the entire path on every hop of how you route something from the UE coming into the 5GC all the way out to the data network. And in that case, your GNOB connects to the N3, so now you need an N3 IP. For DNN, you need to know which DNN it goes out through that UPF and which UE pools that actually draw from. And then if you use IUPF, you also have to tell them what the N9 IP address is. In that case, you can drop the N6, but then you have to tell them the N9. But then the thing that we realized as we start digging into this is that what SMF requires is basically the entire UPF deployment custom resource information. So we created something called ref.nephio.org config, which is basically a embedded type. It embeds the UPF deployment into this reference type. And then the SMF controllers would then read from this config ref and would be able to generate the SMF configurations based on the UPF deployments that are embedded inside. So this is very, I would hope, very unique and specific to free5gc. So we name it a vendor extensions, and the vendor extension is stored, like any vendor extension in the future, hopefully, will be stored in the config ref field of the NF deployment structure. So as you can see from a light demo, and then also what I talked about, the free5gc operator does a lot of things to make sure that, and we did obviously we make a call from UE run-sim, so we have pulled the infrastructure needs outside of the operator, but then also the operators, what it does in terms of configurations and the deployment parameters are all intact and it's validated. but there's still things that it doesn't do. And then we are for release 1, you have to do it manually, which I talked about earlier. For those kernel modules or KOMs that you needed, you have to manually load them onto all the possible nodes that you're going to run that corresponding network functions. And Multis you have to install on all the nodes that you're going to at least spin up an AMF, SMF, or UPF. Basically on all the clusters that you would be creating those network functions. And then the binary needs to be loaded onto the right directory on the node. NADs are actually, I think, to many people's surprise, not done by the free5gc operator. Today it's done by Nephio management cluster. It would automatically generate say, NADs and apply that NADs at the same time it applies the corresponding UPF, SMF, or AMF deployment package. So we have yet to see that NAD loaded after the deployment is done. But then that's the reason why we actually have the code inside the free5gc operator, each of the controllers, to make sure that the NADs that I needed is actually already in place before I call the deployment. Because for Multis, if you are creating a pod, if you attempt to create a pod of that and the annotation with the NAD, with that NAD, but the NAD does not exist, it's a unrecoverable error. So your pod will error out. So it doesn't even reconcile moving forward. So that one that dependencies are very hard dependencies. We have to make sure that that sequence is in place in the code. The NADs right now, based on the Nephio control plane, also explicitly configures the IP address and the gateway IP. So if you look at the annotation, it only needs to map it to a name, which is a predetermined name for us. And likewise, the thing that the CNI configure, which master interface that you're going to use, and what CNI config you're going to use for that NADs. For Nephio, it comes from something called cluster context. And if you do it the way I did things for the demos as I did earlier, then you will have to make your NADs to map to the right interface, and also the correct CNI, which most likely is MAC-VLAN. So in summary, what is actually needed for free5gc, what do we learn actually? The lessons that we learned from building a initial Nephio NF operator, a free5gc one. You have to know your network function very well. I would say this is probably the prep work that needs to be done before writing it. So we do, as I said earlier, one of the design points that we made is the operators would at least manage the network and function configs. So in this case, it's a config map for free5gc. And because it's a config map that needs to be in place and mounted to the pod before you spin up the pod, deployment object therefore needs to be also managed by operator. That's not actually a bad idea, because for UPF, part of the things that we loaded as the deployment is a script, which is also in a config map format, which sets the IP routes on the N6 side. So you know, we probably want to do that intimately onto as close to the workload as possible. So we do that on the operator. And you also have to understand the infrastructure needs of your network functions for it to be deployed. So for free5gcs, we identify all the KLMs, the KLM meaning the kernel modules, the Multis is something that you need to install, and then the binaries and the NADs that are needed. And then you have to understand the network function configurations, which is part of one, but then I break it down into two, because one of them talk about all the things that you have to do for preparing your clusters. And then the second one is understanding when you're writing the operators, you are creating a configurations. So you have to know what configuration you actually want. And you have to then decide if the NF deployment that we use for Nephio, is that enough for operators to generate, say, full network function config, which, to be honest, most of the time, the answer would be no. And anything else you want to do, we have a framework in place. You can add it as part of the network functions project or vendor extension CLDs. And then using those you can also create on management clusters, or you can manually just add and then push it into the same package with UPL, with the network function deployment, and then have the config ref maps to those. So an example of that is something like the SMF config example. If you look at SMF YAML, they have config refs configured. So as I earlier talked about, we defined this raft.nephio.org and config. And then this is basically one of the SMF config refs. And there are two UPF in this case, so there are two refs of the UPFs. And then if you want to take a look at what the refs look like, first refs is basically the entire, we replicated the entire UPF deployment inside this. Again, you only have to, if you use Nephio, you only have to configure once. And then the Nephio management cluster logic would know how to fill all this field. The topology information would also allow them to know which UPF is connected to SMF, and then they would then only extract the connected UPF's information and add it into the SMF deployment. But then if you do it manually, you have to go decide it yourself. You have to make that you have to make that discovery and or configure that yourself. And then in this case, there's also network function dependencies, as I talked about. So this is interesting. We only do it for AMF, SMF, and UPF. We didn't do it for all the other things like NRF, AGSF, UDM, NSSF. So none of this is, all of those are actually spin up for Nephio R1. But then we did it as a package with almost, for most of them, almost no additional parameters needed. All of them basically use Kubernetes interfaces, Ethernet 0 interface, and they'll get the IP address from cluster directly. Each of them has an exposed service directly, but then that's easily decided by embedding the service object template in their package. So in example package under Nephio project, you'll see that we also have all the free5gc packages that aren't, so those things are done as static, if you will, packages. There's logic inside the pipeline that would be deploying them, but then it's actually, I don't think any of them has parameters that needs to be added. So you basically they are really static packages. Then corresponding network functions get created, and then they communicate with each other using HTTP on a service bus, which is well supported obviously by Kubernetes network, any of the Kubernetes networking, any CNI you use. So we didn't honestly go through the trouble of going to figure out which of the network function are needed or not needed to make a call. So we spin them all up, but then they're simple to spin up. The only thing we need to do was AMF, SMF, and UPF. So those are more operator-based versus package or static package-based deployments. So if you do the full end-to-end test or deployment that I'm sure earlier learning sessions that you've seen, the packages are already part of the execution of the end-to-end test, and they are basically just deployed. So you're doing that, you'll see that your workload cluster would have all the network functions deployed on free5gc or free5gc CP namespace. And this is it from free5gc operator. Thank you.